So if you remember last week, we were talking about sorting. I think we talked about two different kinds, a bubble sort and a selection sort. The way selection sort looks is it searches the entire array for the smallest value, or the largest if that's where we're going, and it moves it, swaps it to the front, and then it looks at the rest of the array for the next largest value and puts it in position 2, and the next largest value and puts it in position 3, and so on until it's, all sorted correctly. That's a selection sort. And I think it'd be worth us going ahead and try to program it without looking at the source code here. In order to do that, we're going to need to remember how you swap two elements of an array. And to do that, you need to have a temporary variable, right? Because if I have two oranges, or an orange and an apple, and I want to swap their hands, unless I'm a juggler, right? But computers can't juggle. I can't do that. I have to hand one of the oranges to you, move the apple into the other hand, and then I can take the orange back, right? So we're going to need temporary variables in order to swap two elements of an array. I'm going to launch NetBeans and go ahead and play with that. So I'm contemplating how complex to make this, right? We could stick all this stuff in its own class, and then we could have, a driver that runs it. I think I'm going to not make it that complicated, and I'm just going to make the array a static member of the driver class. And we're not going to even have another class at this point. Why am I making it static? Because main is static, and it can only access other static members and methods of the same class. So are we on V? Yep. All right. New project. Next. Picture V. All right, now we could be real cool and make an array and fill it with random data and stuff like that, but let's just declare, an array and stick some numbers in it ourselves. So we're going to use an initializing list. So, all right, how about an array of ints? Int, I'm not calling it data, but I forgot I need to make it static since we're going to be accessing it from within main and maybe some other static methods in the same class. And I've done that wrong. That's the C++ style of doing it. Static int, square braces, data equals, and then some curly braces, and then just type some numbers in. It doesn't matter what order they're in. Don't type the same numbers I do. All right, I'm just typing them in at random. No rhyme or reason. When I'm done, I'm hoping this data winds up being sorted. So the way the sort algorithm is going to work is it's going to go, okay, I need the largest value. And it's going to search the entire array, finding the largest value, which is 41, and it's going to record what index that's at. 1, 2, 0, 1, 2, 3, 4, 5, 6, right? And then it's going to go all the way down, and it doesn't find any other, so it knows that it needs to swap the first element in 6. Then it's going to search the rest of the array for the next largest value. I'm going to cheat and make, one of those the next largest. Okay, so it's going to look and it's going to find, oh, we have the next largest at element 5. And once it hits the end of it, it's going to swap that one with that one. And it's going to keep doing that. So we're going to need a nested loop. The outer loop is going to go item by item, right? It's going to look for what goes in that position, and then it's going to look for what goes in that position, and then it's going to look for what goes in that position. The inner loop is going to scan the rest of the array, trying to find the largest value so that it can then do a swap. But let's write a swap method, just so that we don't have to put these 3 lines of code every time we want to swap elements in our primary algorithm. So static void, it doesn't need to return anything. Swap int, how about I for index 1, int I2. Index 1, index 2, or we could have called them A and B, something like that. It doesn't matter. How about A and B? I like that. A and B. So like I said, if you swap two elements, and it doesn't matter if they're in an array or not, anytime you're going to swap two variables, you need to do this technique. You declare a temporary variable, and you set it equal to one of the values, so data subscript A, and then we can erase that value and copy the other value into it. So data subscript A is equal to data subscript B, and then data subscript B is equal to 10. That makes sense? That performs a swap of the two specified indexes. All right, so I'm going to write some loops here. A nested loop. One that's going to count from here to here. In other words, it's going to count from 0 to length minus 2. Why not length minus 1? Because by the time you've gone through the rest of them, then the last one's going to be in its right place. So, for int first, just need a variable name. Equals 0, first is less than data dot length minus 2, first plus plus. Each pass, the first time, it's going to equal 0. And so we're going to scan the rest of the array looking for that largest value. I don't like that comment here. I'm going to get rid of that. Save a little bit more space by doing that. Alrighty, now the inner loop is going to count from 1 after first, right? Because if we're looking here and we need to find the largest value, we're going to have to scan from there to there. Now I really can't think of a clever name for this one at all. So for int, whatever. Possible? I don't know. I'm just going to call it I. Boring, stupid. I is equal to first plus 1. I is less than data dot length. Oh, I made a mistake here. This either needs to be less than or equal data length minus 2, or just needs to be less than data length minus 1. I've kind of botched those. So I'm going to change this to minus 1 here. Now make sure you get that change in, or else the last element's not going to be sorted. Alrighty. And then I plus plus. So we're going to need a variable that holds the index of the largest value. We're going to scan through the array looking for the index of the largest value. When we start scanning here, we're going to find that one. It's going to be at index 0, 1, 2, 3, 4, 5, 6, right? So we need a variable name that indicates what that is. Yes, sir? All righty. Int, how about IDX for index, underscore largest equals 0, right? Until we find a larger one. No, how about IDX largest is equal to first. We're just going to assume that the first value is the largest until proven otherwise. Now we're going to compare them. So, if, parentheses, data subscript I is greater than data subscript index of the largest, IDX underscore largest, then IDX largest becomes I, right? We have found a new largest element, so we need to record its position. Once that inner loop is done, we need to swap. We need to swap the first element with the largest element. Let's do that. Swap first, and then the index of the largest found. And then let's print the array, just so we can watch it change. System.out.println, and we're going to use arrays.toString. You know, we could write our own for loop. Why don't we do that? Don't be lazy, Jeff. For parentheses int value colon data, for every value in the data, system.out.print value followed by a space. And then after our loop, we're going to print line. System.out.println. So we should see the values swap as we go through it, right? If this thing is 12 lines long, 12 elements in the array, we ought to see about 12 different lines of data showing all the elements being swapped. If we were to add some comments, which we probably should, we would, and let's see how well they commented theirs. Yeah, look at that. Not a single comment in their example. All right, I'm going to check out their variable names, though. They did min and min index. Min index would have been a good name for that variable. Better than mine. And start index rather than first would have been a better variable name. I'm going to go ahead and make those changes. Instead of first, I don't know if I need to make that change, but IDX largest, let's call that min or max underscore index. That's a better name. So I'm going to right click on that variable name. Do refactor, I'm going to do it from up here, it's easier. Refactor, rename, and call it index underscore max. I think that's a better variable name. And I is really cheesy, so I could call it current. But I'm going to leave it I. But I could refactor it and give it a better variable name. I can't help it. I want to refactor it. So I'm going to highlight I, refactor, rename, call it current. See, it's okay to choose cheesy variable names and then go back and fix them up. I think that'll work. Hope so, because I'm going to run it. Hope it doesn't blow up. Whoa. Clean and rebuild. Now run it. Oh, now it worked. Okay. So, after the first swap, the 41 went to the beginning. After the second swap, the 35 went to the beginning. After the third swap, the 8 went to the beginning. After the fourth swap, the 7 went. After the fifth, the 6 went. After the 6th, you know. And eventually, you know, as we keep putting them in place, they become, you know, completely sorted. Now check it out. At this point, the data is already sorted. We could put some checks in there that if it ran all the way through the loop without finding anything to swap, then we're going to break out of the loop. We don't need to keep running, right? Because what if the data was already sorted right from the get-go? Would we really want to process this loop 20 times, doing 20 comparisons or whatever, if the data was already sorted from the get-go? So we could provide an optimization. To do that, right, we might just want to keep track of how many swaps we had to do. Now I'm not going to bother doing that. But conceptually you can see what I mean, right? Because if the data is already sorted.
I might have done something wrong, because when I printed mine out, 9 is before 56.
All right, let me come look.
No, then, nine with them.
All right, a couple of things to point out. If you have the swap inside the inner for loop, it doesn't work very well. Might work, might not. You only want to swap it after you've searched the entire array for the largest. So it has to be outside the inner loop. So it's got to be there. Another is that we made it so that it's sorted in reverse order, largest. If you want it sorted in, from small to large, all you got to do is change that greater to a less than. But then this index max, we might want to rename it to index min or something like that. But if you change that, then it'll just wind up being sorted, right, from small to large. And quite often, that's really what we want. But I like thinking in terms of swapping the largest value in rather than swapping the smallest value in. All I did is I changed this if statement, greater than to a less than, and it swapped it and sorted it in reverse order. I'm going to change it back, though. All right, so we've done one sort. I'm not going to bother, right, doing another sort, bubble sort. If we wanted to make this a little bit better, we would make it so that we passed in the array as a parameter, right? That way it would work on different arrays, right? Because maybe we're not only swapping on one array, maybe we don't want to, that would be a better thing to do. So let's go ahead and make that change. Up here, inside our swap, do this. Int subscript in subscript, and let's just call it array. And then change these words data to array. And then let's move the allocation of this array to inside main. It doesn't need to be a class member. It's just going to be a local variable, part of main. Now when we paste it, we're going to have to delete the word static. But anyway, so I'm going to take my array declaration. I'm going to cut it. I'm going to come down here to main, and I'm going to paste it and remove that word static. All right, now, whoops, not static in. Just get rid of the word static, my mistake. Now I've got one error. The error is my swap call. What do I need to do to fix that? We have 3 parameters now rather than 2. What's the first parameter supposed to be?
Array.
Needs to be array, correct. All right. No, and it's not called array. What's it really called? What is our array called in here?
Data.
Right, so let's make it data. I'm sure I pronounce it data all the time, and I guess I'm just too big of a Star Trek fan. Data is correct. All right, then I'm going to run it, make sure it works. Yeah, okay, all right. Now why would I do that? I might want to move all this stuff into another class, right, and make it kind of generic so you could do all this stuff with multiple arrays. Now it'd be really neat if we took this entire for loop and made it its own method. I'm going to see if I can do that with refactor. Here's a trick for moving stuff into its own method. It might not work. We might undo it, so you might just watch me do it first rather than do it as I do it. I'm going to highlight everything from the for loop all the way down here to the last closing brace there. Not this one, because this is the end of main. Yeah.
Sorry.
And this is the end of the class. So we've seen refactor used for two things so far, I believe. One is for generating, getters and setters, and one for renaming. There's another one. It'll create methods for you if you highlight some code and then tell it to extract that into its own method. So I'm going to take everything from the for loop down to the closing brace of the for loop. Not the final two closing braces, but the one above it. And then choose refactor. Where is it? Where is it? Where is it? Maybe it's introduce. Introduce method. Why do I have a bad feeling about this? And I'm going to call the method sort. All right, and look what it did. It created a method called sort, and it moved all of our code into it. So when I come down to look at, or when I scroll up and look at main, isn't that sweet? Doesn't that look neat? So you can take chunks of code and you can try to modularize it by letting refactor do it for you. But sometimes the results are really weird. I'm just going to take a random chunk of code and do the same thing and see if it works, see if it doesn't. Introduce a method. Alrighty, I don't even know what I'm going to call this. I'm going to undo this immediately. Well, that's not a bad change, but I don't want to keep messing with the code to make it impossible to understand. But if I was going to do that, let me show you why I say it's not a bad change. What I did is I took the inner loop. I'm going to convert it to a method, and I'm going to call it search for largest. And now look at that loop. It's an outer loop. I'm going to undo that change, like I said. And then it calls a function called search for largest that passes in the array, and then it returns it. Kind of neat. Kind of neat. Now, when you do that, it doesn't always do a great job. Sometimes it winds up, passing in too many different values here. It creates a whole bunch of spurious parameters, and so sometimes it's not the greatest thing. But it did that other one real nicely. It made a really nice sort method. So I like that. I like the way it looks. That way, anytime we had an array, we could just call sort, right? If I made up a new one, int data2 is equal to, and I'm going to make it the worst case scenario where the data is already sorted but in the wrong order, right? And then I'm going to sort that, sort data2. Alrighty, I hope it worked. There we go. Wait. Okay, so the 10 got moved to the front, and then the 9 did, and then the 8 did, and then the 7 did. So you can see it's kind of the worst case. It's having to do, a swap on every single piece of data, where sometimes it was able to skip doing swaps if we did this. One optimization we could do, I'm not going to talk about optimization. When you do a swap, if the index numbers are the same, you don't even need to do that swap, right? That just takes extra cycles to do that swap. If if A and B are the same, right? Then we could comment that out, and if we thought that was going to be a common occurrence. So yeah, I'll show you where I would add it, but then I don't think I'm going to actually make that change. Right here, before we swap it, we could do if first not equal index max, right? Because if both of those are the same, then swapping them ain't going to do anything, right? It's just like I take, 2 oranges and but I'm holding them in the same place. So I could optimize it there. Let's not. So two-dimensional arrays. A two-dimensional array is a grid, a matrix. It's also considered an array of arrays. Here we have an array that's got two little arrays in it, right? It's got an array of length 2, and then each of those elements has got 3 elements in it. But overall, it makes up a grid, right? And so this would be element 0, 0. That would be element 0, 1. That would be element 0, 2. This would be 1, 0, 1, 1, and 1, 2. And so our syntax there is the first index is the row, and the second index is the column. So that's row 0, column 0. Row 0, column 1. Row 0, column 2. Row 1, column 0. Row 1, column 1, and so on. And so that's what we're seeing here. Let's declare a two-dimensional array. This index is going to look a little bit goofy, just because I'm not going to fill it with random data. Again, I'm going to use an initializer list, but the initializer list for creating a two-dimensional array looks gnarly, and the C++ students have already done this, so you know what I mean. Let me find main, wherever main is. Okay. So I'm going to declare two-dimensional array events. And I hope that's the correct syntax. Let me validate that before we go on. Yep. All right. And so I want it to be 2 rows of 4 elements. I'm just going to call it TDA for two-dimensional array. So int subscript with no numbers in there, TDA equals open brace, and on the next line do another open brace, and then type in, like, what did I say, it was going to be a 3x4 array? I don't remember. 10, 20, 30, 40, end, curly brace, comma, and the numbers don't matter, just, 5, 4, 5, comma, 4, comma, 3, comma, 2, end, brace, comma, and then 0, comma, 1, comma, 2, comma, 3. And the last one doesn't need a comma because it's the last row. So each one of these is a row in our grid. And we can see that it's an array of arrays, so to speak. So if we want to change this 0 to something else before we print it out, well, let's print it out first, just to make sure that our prediction is correct. Print line, whatever. TDA subscript, what row is it? It's in row 2, right? Because that's row 0, that's row 1, row 2. So TDA subscript 0 in subscript, wait, not 0. What row is it? Which row is this? Well, if this is row 0 and this is row 1, then this is row... Come on, somebody say it. Could be a long night. If that's row 0, then this is row 1 and this is row...
3 or 2?
2. Yeah. All right. And so what is the index number of that? 0 there in this row. What column is it? Starting at 0. Column 0, column 1, column 2, comma 3, right? Because we always start counting at 0. So this is a TDA 2 subscript 0. And when I do that, it's going to print 0. Let's print this one out. Somebody tell me what row that one is. Come on, guys.
That's row 3.
It's column 3. But each one of these is a row, so is it the first, second, or third row? It's the first one, so that makes it row number what? 0-based indexing, that's row 0. This is row 1, and this is row 2. So system.out.println, TDA, subscript 0. Now what's its column number? Now Daniel, you just had it. What's the column number of this one? Don't make me start picking names and put people on the spot. Yep, 3. All right. So when we run it, the first number printed out is going to be a 0, and the second number printed out is going to be a 40. All right, and as predicted. Okay. So here I'm going to do system. Now I'm going to change one of the values. TDA subscript 2 and subscript. No. I want to do 1, 1. And I'm going to set it equal to, 33, just so it'll leap out if we ever print the array. Which one is 1, 1? If I gave you this array, what is the current value of position 1, 1 before this happens? Somebody tell me where row 1, column 1 is. What value is it?
4.
It is 4, exactly. Because that's row 0, so that's row 1. That's column 0, that's column 1. And so that will change that 4 to a 33. Now let's print it out. To print out a 2-dimensional array, you need a nested loop. And you need two counters. You need a row counter and you need a column counter. And I'm going to cheat and I'm going to hard code the values 4 and 3 into my for loops, but that's wrong. I should not do it that way, and so I will fix it. And since I'm saying it's wrong, then when I ask you to do it on an exam, don't do it the wrong way. But just for clarity, to make it simple as possible the first time we see it, for int r for row equals 0. R is less than how many rows do we have? 3. R plus plus. And our inner loop. For parentheses int c is equal to 0. How many columns do we have?
We have 3. We have 4.
We have 4 columns, right? So c is less than 4. C plus plus. And in here, I'm going to use printf just so that I can specify the width of it, right? So that they'll be, all lined up. So system.out.printf parentheses quote %4d, right? We're going to put 4 spaces for every number. End quote, comma, TDA, subscript R, subscript C. In subscript, in parentheses, semicolon. Now, after the inner loop, right, we've just printed a whole bunch of elements in a row. We've just printed out every column. Once we print out the last column, we need to hit the enter key. So we're going to do a system.out.println here. System.out.println. I'll come look. Okay, and there's our array. We did change that element to 33. It printed it out as a grid, row by column. But I don't want to hard code that as 3. I want to check the array and ask it how many rows there are. And the way I do that is just with dot length again. TDA dot length. Now how do we get that 4th? That number 4. Change that to TDA subscript row in subscript dot length. How many columns are in this row? And by the way, it's not row, it's just R. Sorry, my mistake. Unless I do a rename and rename all of my R's to row. Now to work, and we don't have those hard-coded literals, those constants. Much better. Now I'm going to show you something weird, which is what happened if one of these had too many pieces of data in it, right, like that.
Or suppose they did not have enough.
Yeah, or not enough. So like what if this one only had 2? I'm going to probably undo those changes because it's going to make our output look dumb. But there we go. In this language, it is legal to have more columns in one row than another one. That's called a ragged array or a jagged array, right? That rows 0 had 4 elements, this one had 10 or whatever that is, and row 2 has 2 elements, 2 columns. So it is okay, if you define it with an initializer list, to have an array where each row doesn't have the same number of columns. And I'm going to undo that because I like a nice tidy square array.
Something I still don't know is complaining about. Well, was not to say complaining to something.
All right, I'll come look.
Right.
Now, the point that I was going to make is that if this still equaled, 3, and this still equaled 4, or vice versa, then it wouldn't print out the entire thing, or it would blow up, right? Because each column is of a different length. So we couldn't hard code 4 right there. That's why we use TDA subscript.length. All right, let me come see what's going on. Well, let me make sure it works first. Then let me undo my changes to my array. All right, now we're good to go. It turned out that I typed too quickly, and where I typed too quickly is in our for loop, and I was removing the hard-coded constants. This one, the outer loop needs to be dot length, and this inner one needs to be subscript r dot length. So for you students taking C, I want to make a few comments. Everybody else can just plug your ears and go la la la. C doesn't have a dot length operator. So you have to keep track of how many rows you have. You'd have to make a variable that said 3. And you'd have to make another variable that said 4. And that's a real pain. It's a real pain that you have to keep track of those. And another implication of that is that you cannot have jagged arrays in C. Can in this language, though, for whatever purposes. Okay, so if you were going to write some code that would sum up all the data in this array, you would just need another nested loop. Let's add all the numbers in that array. And again, it's just going to be a nested loop. But we're going to need a variable to contain the total, right? And I like making them doubles so that if we do some division later, we don't wind up with, integer division rounding down. So double total equals 0, and now we need an outer loop and an inner loop. Same syntax as the other one. We could just copy and paste, but we're going to type it. Int r is equal to 0, r is less than, now how do we get the length, the number of rows? TDA.length, r++. And then the inner loop. For int c is equal to 0, c is less than, and how do we get the length of how many columns is in this row? TDA subscript what? What do I put inside the subscript there to get the number of columns in this row? Scroll down to the other for loop if you gotta. I know somebody can scroll down, hit the other for loop, and tell me what subscript goes there.
R.
Yeah. All right. And then total plus equals TDA subscript R subscript C. Oh, and I have a mistake in my for line here. What's wrong with this for line?
Which one? Oh, they have no update. So
Right, I have no update, so I need to put a semicolon and a C++ there. And then if I wanted to, I could print the total out. Why not? System.out.println 2D array total equals end quote plus total parentheses semicolon. Oh, and I did that before I made all these changes, so the total is not going to match, right? Because I changed one of these to 33, whatever. Just demonstration code. All right, the total before we change that to 33 is 40. why don't I go ahead and move these three statements up above my total loop? I'm going to highlight those guys, those three statements, cut them, come up here, paste, and then I'm going to add some comments. Calculate sum of 2D array. And then I'm going to come down here and add another comment. Print 2D array as a grid. Anybody got a problem with this chunk of code right here? Is that breaking for you? So to print a 2D array, it has to be a nested loop. To calculate the sum of it, it's going to be a nested loop. What if it's a 3D array? Then it's going to be a triply nested loop, right? You're going to have one for loop and another one inside that and another one inside that. Now a three-dimensional array we can kind of imagine because it's like three-dimensional space, right? You have an x and a y and a z coordinate. How about a fourth-dimensional array or a fifth, 5 dimensions or whatever? Yeah, you can make those in the language. It's just hard for us to visualize in our heads. So arrays of objects. I think I've already demonstrated this. Maybe not. You can have an array of objects. If we had an array of strings, we already have an array of objects. But let's create some simple kind of array, some simple kind of class, and then we're going to add the elements of that, objects of that type into an array. So let's scroll up above our class definition, and we're going to make a silly class that's just got 2 pieces of information. Maybe even 1. We're going to make a circle class. So class circle, and as usual, double radius, and then let's write an area function for it, because getting the area of a circle is our favorite thing to do. Double get area, parentheses in parentheses, and so let's just return, what's the area? Pi r squared. Return math.pi times radius, or if you feel like using math.pow, whatever. Okay, there, we have a cute little circle class. I'm going to wait for everybody to get that typed in, because then I'm going to scroll down to main and I'm going to create some objects and add them to an array. Everybody got this part? Wave your hand if not, because I'm scrolling down to main. You won't be able to see it anymore. We all good? All right. Scrolling down to main. Where's main? I've lost main. Here we go. Let's create an array of circles. Circle, subscript, just a one-dimensional array. CARR for circle array, something like that. Equals new circle, capital C, and I want 4 circles in my array. Now let's stick some items in it. CARR subscript 0 is equal to new circle subscript in subscript, like that. I've got a problem here. This is not going to look too cool, but let's just run with it. Circle subscript 1 is equal to new circle CARR subscript 2 is equal to new circle, and CARR subscript 3 is equal to new circle. Now the problem is that they're all radius 0, but we can fix that. CARR subscript 0 dot radius is equal to, and just pick a number. And then do that for the other three elements of the array. CARR subscript 1 dot radius is equal to 20 or something. CARR subscript 2 is equal to 40. And CARR subscript 3 is equal to 8. And then we could write a loop that would print those out. So I'm going to use a range-based loop. I'm going to use a for each loop just to step through our array of circles. So for, and what? This is an array of circles. So for circle C colon CARR, for every circle in the circle array, let's print out system.out.print F circle radius equals percent F comma area equals percent F backslash n end quote comma, and then we need to pass in some data to fill in those two placeholders. So C dot radius comma C dot get area. So when it runs, we should see that there's 4 circles with radius 10, 20, 40, and 80, and we should see their area. More commonly, you put this kind of stuff in a loop, right? You could have a loop creating circles, and you could be asking the user for the radiuses, or you could be calculating random radiuses or something like that, reading them from a file. I wonder if it's going to work. Hope so. Scroll back up to the top. Here's our circles. Excuse me while I move this up here so I can see it. Yep, there's my radiuses and my areas. What would happen if we had this for loop before we did this step? Don't do this because this is going to blow up, right? But I took my printing loop and I'm going to move it right here to there. And it's going to blow up. Now, why did it blow up? Null pointer exception. What does that mean? It means that there's no circles in it. It's got room for 4 circles, but those are just references. It's got 4 references, but they're all initialized to null. If we printed out the references, they would all say null. And then later on, if we printed out the references again, they would have some, memory address stored in them. It's only after you create a new object of that type and store it into the array that you can access it. I'll show you what I mean. And I would like for you to do this part. We're going to change this just a little bit. Make your code look like this, and I'm not going to even read it aloud. I'll read it aloud as soon as I've typed it. All right, like that. Printf %s backslash n comma c. And then copy that for loop and put it after the creation of the 4 circles. So this code's going to be duplicated. It's going to be before the new circle, new circle, new circle, and it's going to be after it. So as soon as you get that typed in, paste it down here. Tidy it up. And we're going to be about done after this. So, the 4 circles in the array is just 4 nulls because there haven't been any circles created yet. After they get created with the new keyword, then we have 4 circles, and those are their addresses in memory, right? 15db9742, and that one, and that one, and that one. Hope that kind of makes sense. Just because you allocate an array of objects doesn't mean those objects are created. It's just got space for 4 references to objects. This creates the array. This creates the objects that go into that array. We could have changed this syntax up a little bit. Well, we could have made a constructor, right, so that we could pass in the radius and it would be all cool and stuff. I think that's a good enough example for now. By the way, these are known as anonymous objects. They don't have names, right? We did new circle, but we didn't give it a name. Here's what I did not do, and I'm going to delete it as soon as I type it, so don't type it. Circle C1 is equal to new circle, right? That circle has a name. This one doesn't. The reference is stored directly into an array. So this is an anonymous object. We still have a reference to it, though. All right. Anybody need help? No typos? All right. I didn't lose you. Have to try harder next time. I'd like to make one change to these print statements. In front of the %s, do %d space. No, that's not going to work. Never mind. We don't even have an index-based counter, so I'm not going to be able to do what I was trying. Undo that, and we're going to stop here.